All right, diving deep today, we're taking on this paper all about using game theory to boost efficiency in fog computing.
Yeah, the title's a bit of a
I
mouthful.
was going to say GAP, game theory-based approach for reliability and power management in emerging fog computing. Definitely needed an expert to help us out with this one.
Well, happy to be here. And you're right, this paper really digs into a pretty big issue.
For sure, but before we get too technical, maybe a quick reminder of what fog computing is. For anyone just joining us.
Okay, so imagine this. Your self-driving car suddenly needs to make a super fast decision to avoid an obstacle.
Oh, like a quick swerve or something.
Exactly. But sending all that data from the car's sensors up to the cloud, processing it, then getting an answer back.
Wow.
Way too slow.
Yeah, could be dangerous.
Exactly. So fog computing basically puts a little mini cloud closer to the action, right there in the car.
Ah, so it can process everything right on the spot.
Exactly. Keeps everything running smoothly and super fast.
It's like having a super brain right where you need it.
Oop.
But this paper highlights a problem with that, right? Unlimited power isn't really an option.
You got it. We want these fog nodes, the little computing units, to be powerful, sure, but they also can't just guzzle energy, especially if they're running on, say, a car battery.
Yeah, makes sense.
That's the balancing act this paper is trying to solve.
And I imagine this is only going to get tougher, right? With all the smart homes and wearables and sensors everywhere.
You're telling me mountains of data all needing to be processed?
So the old ways of managing all that just aren't cutting it anymore.
Not really. Some are too rigid, some don't scale well, and some just can't seem to balance speed and energy use.
Okay, so that's where this GP solution comes in.
Right. That stands for Game Theory-Based Approach for Reliability and Power Management.
Interesting. So they're treating this whole thing like a game.
It's kind of like that, yeah.
But how does that actually work? How does thinking of it as a game help with power and reliability?
Okay, so think of each task, like processing data from a sensor or something, as a player.
Okay, I'm following.
Each player wants to win, of course, get its needs met.
Mm.
But the game itself, the way it's designed, it actually figures out the best way for everyone to win.
Ah, so it finds the best solution for low power use and high reliability at the same time.
You got it. It's all about sharing resources in the smartest way possible.
Okay. Like a giant puzzle you have to solve.
It is pretty complex. Maybe a real-world analogy might help.
Yeah, always good.
Okay, picture a crazy, busy restaurant kitchen, right?
Right. Lots of chefs running around.
Exactly. Limited ovens, limited cooks, ingredients.
Orders coming in like crazy.
And you got to figure out how to get all those dishes cooked, out to the customers on time, no wasted energy, nothing gets burnt.
Wow, that's a lot to juggle.
It is.
So is GAP kind of like the head chef in this scenario?
Yeah, like that, making sure everything runs smoothly, nothing gets overcooked.
Perfect. So what are its secret ingredients for success?
Well, two main techniques. The first is called dynamic voltage and frequency scaling, or DVFS.
Okay, DVFS. I'm guessing that needs a bit more explanation.
Think about the gas pedal in a car, right?
Right, yeah.
Sometimes you got to floor it to go fast. Sometimes you can just coast and save fuel.
Right.
DDFS lets the fog nodes kind of adjust their speed, how much processing power they use, depending on the task.
Oh, so if it needs max power, it goes full throttle, but if it can coast...
It coasts, saves energy.
That makes sense.
They found that just using DVFS can cut energy use by up to 35%.
Wow, that's huge. Like our phones lasting way longer on one charge.
Wouldn't that be nice?
Definitely would. Okay, so DVFS is for efficiency. What about making sure everything runs smoothly all the time? What's the other trick?
That's where cold primary backup comes in, CPB.
Ah, CPB.
Yeah.
And that's all about having a backup ready just in case, right?
Exactly. Like an understudy for a play.
Oh, right. Ready to step in if the lead actor can't go on.
Perfect example.
Okay.
So say you're streaming a movie on your phone.
Yeah.
And the main fog node handling it has a problem.
Oh, no.
CPB means there's a backup node all ready to go, takes over instantly.
So you don't even notice a glitch.
Seamless. All about reliability.
Okay, I'm starting to see the whole picture.
Yeah.
We've got the game setting the rules, DVFS is the smart gas pedal, CPB keeping things running no matter what.
Yep.
But how does GAP actually make all this work together?
It's like a really well-rehearsed dance routine. First, GAP looks at all the tasks, figures out which ones are urgent. It's like a really well-rehearsed dance routine. First, GAP looks at all the tasks, figures out which ones are urgent.
So like a triage system in a hospital. The most critical cases get attention first.
Exactly. Then it assigns those tasks to the right fog nodes based on how much processing power each task needs.
Oh, so it's not just randomly throwing work at the closest node.
Nope, got to be strategic, make sure no one node gets overloaded,
Yeah.
and that's where DVFS comes in.
Ah, right, the smart gas pedal.
It fine-tunes how much power each node uses, making sure tasks are done on time, but without wasting energy. And of course, we've got CPB in the background, ready to jump in if there's trouble.
It all sounds so well coordinated.
It is, like a well-oiled machine.
But does it actually work that well in practice? Did they actually test this out?
Oh yeah, they ran simulations using iFog Sims.
iFog.
It's like a virtual test environment for fog computing systems.
Ah, okay.
And even without using DVFS, GAP used way less energy than other methods.
So it's already winning right out of the gate.
Pretty much. And when they did add DVFS,
Even better.
the energy savings were huge, like high performance and low power use at the same time.
Nice. But what about speed? Did it actually finish tasks quickly?
Oh yeah, flew through them. Even with a heavy workload. Minimize those wait times to make sure deadlines were met. It's efficient.
Looking at the results here, there's something kind of interesting. GAP actually did better than some methods that, on paper, seemed more energy efficient. How's it possible?
That's a great catch. And it shows something important about this research. Sometimes using the absolute least amount of power isn't always the best for overall energy efficiency.
Oh, okay.
Think of it like, if you drive really slowly to save gas, you might end up using more fuel because the trip takes so long.
Ah, right. Sometimes it's better to just get there quickly.
Exactly. GAP, by being smart about which tasks are important and how to use the fog nodes, it finds that balance, speed and efficiency.
So it gets things done fast, which actually saves energy in the long run.
You got it.
So basically, by using game theory, they've made fog computing better in every way.
Pretty much. And that's a big deal for all our smart devices and the crazy amount of data they create.
Totally.
But what's really cool is how this approach could go way beyond fog computing.
Oh, you mean like used in other areas?
Yeah. Think about managing power on a spacecraft. Every little bit counts there. Or scheduling surgeries in a hospital. You've got limited rooms, limited doctors.
Right. You can't just add more whenever you want.
Exactly.
Yeah.
Even something like traffic in a smart city, trying to keep everything flowing smoothly.
So we started with this one problem, making fog computing better, but now we're talking about...
All sorts of things.
Yeah.
It's like this new way to think about managing resources in general.
Pretty amazing, this research. It's like they've just scratched the surface.
It does feel that way.
Yeah.
The more we learn about building smart systems that can adapt and optimize.
The more possibilities open up.
Exactly.
Makes you think about all the data we create.
It is a lot.
Needing these efficient and reliable systems, it's pretty crucial.
Yeah, it's a big turning point in how we use technology.
Are there any particular applications that that really stand out to you, ones you're excited about?
That's a great question. I think this type of optimization could revolutionize personalized medicine.
Personalized medicine.
Yeah.
Wouldn't have thought of that right away, but yeah, I can see the connection. Tell me more.
Well, imagine a future where everyone has a digital twin.
A digital twin.
A virtual model of you. It includes your genes, your lifestyle, all your medical history.
Wow.
And instead of treating everyone the same way, doctors could create custom treatment plans.
So healthcare tailored to you. That's incredible. But wouldn't that take a ton of computing power?
It would, which is where fog computing comes in. Algorithms like GAP could spread that work across a network of fog nodes. No need for those giant data centers.
That changes everything. And not just for medicine.
Right. Drug discovery, tracking diseases.
So many possibilities. It's almost like we're entering a new era of computing. Intelligence woven into every part of our lives.
Making things smoother, more efficient.
Exciting stuff. But with all this talk about efficiency, optimization, there's something we haven't really talked about yet.
What's that?
The human side of things.
Humans?
The human side of things. Yeah, we can't just talk about all these algorithms without thinking about how they affect people.
Exactly. It's like, you build this super fast car, but you forget the brakes.
Ooh, I like that analogy. It could be dangerous.
Definitely. So, as we keep going deeper into these intelligent systems, what are some of the things we should be careful about?
That's a good question.
Well, one that comes up a lot is, these systems can pick up biases from the data they learn from.
Oh, so like if it's designed to help with hiring, but the data it's using is already biased, it'll just keep making those same unfair choices.
Exactly. We got to be really careful about how we design them and what data they use. It's not just about efficiency.
Right. Fairness matters too.
It does. It reminds us that even the smartest technology, it's still made by people. We can't just blame the algorithms if something goes wrong.
True. It all comes back to human choices.
Right. And another thing is transparency.
Transparency.
Yeah, as these systems get more complex, it's harder to figure out how they work, what's driving their decisions.
So it's like a black box. You put data in, get an answer out, but you don't know what happened in the middle.
Right. And that could be a problem.
Because you can't trust something if you don't know how it works.
Exactly. If something goes wrong, you need to be able to retrace the steps, understand why a certain decision was made.
Makes sense. With great power comes great responsibility.
Right. Exactly. We're giving these systems a lot of power,
Yeah.
so we have to make sure they're using it responsibly.
So how do we do that? How do we make sure these advances help everyone, not just a few?
Well, I think staying informed is a big part of it. The more we understand about these technologies, the better we can advocate for their responsible use.
Which is where conversations like this one come in, breaking down these complex ideas so everyone can understand them.
Right. And we can support those organizations and projects that are pushing for ethical AI.
The ones developing guidelines, working with policymakers, keeping tech companies in check.
Yes. And as consumers, we can choose to support companies that are doing things the right way.
Right, voting with our wallets.
And it's really important to have different perspectives involved when these technologies are being built.
So people from all walks of life, making sure the people making the decisions reflect the people who will be affected by them.
Exactly. It's all connected, you know.
It is. Education, awareness, diversity, making our voices heard.
It's about shaping a future where technology really benefits everyone.
Well said. This has been a really fascinating deep dive.
It has.
We started with making fog computing more efficient, and now we're talking about the future of humanity.
It's amazing how these things connect, isn't it?
It is. And if there's one thing I want listeners to take away from this, it's that the future of tech isn't some fixed thing.
Right.
It's something we're building with every choice we make.
I like that. It's exciting and a little scary. But it's up to us to make sure these powerful tools are used for good.
Let's make good choices then. Thanks for joining us for this deep dive. Until next time, keep those brains buzzing. And remember, the future is what we make it.
Absolutely. It was a pleasure being here.